I'm Nia.
And I'm Cameron.
And the project we decided to research and experiment was antibiotic resistance.
What exactly is antibiotic resistance? Well, according to medicine.net, the definition is the ability of bacteria and other microorganisms to resist the effects of antibiotics to which they were once sensitive. Antibiotic resistance is a major concern of overuse of antibiotics, also known as drug resistance.
Antibiotic resistance occurs when strains of bacteria become unaffected by the antibiotics used originally against them. This science fair project aims to find out how the frequent use of antibiotics affects bacterial resistance. This experiment is carried out using the antibiotic ampicillin and the bacteria, aka E. coli.
The purpose of this experiment was to determine how well various antibiotics would destroy bacteria. We all get sick and have probably wondered how thoroughly the antibiotic that we are taking killed off the bad bacteria cells. The information gained from the experiment would allow the medical society to know which antibiotic kills bacteria the best.
The procedure that we followed was pretty simple. We prepared the petri dishes using agar and stored them in the fridge. We then labeled the dishes. Eventually, we prepared the antibiotic mixture. Then, we mixed the E. coli bacteria with water and swiped over the agar surface. After that, we punched holes in the filter paper and covered the petri dishes, each one labeled with the number of antibiotics we used. We then waited for 4 days or until a circular area around the filter paper appeared. After it was grown, we collected the surviving bacteria from the inhabitation zone and prepare bacteria for subsequent experiments.
Here's our table and graph, which shows our results. The table is made up of the amount of ampicillin we use for each petri dish, which also includes the inhabitation zone that was featured on the petri dish, which changed during each trial. With each generation, the inhabitation zone grows smaller in diameter. Also, the higher the concentration of the antibiotic used, the bigger the diameter of the inhabitation zone. This is a graph of the version of our table.
Our hypothesis was that the bacteria would become resistant to the antibiotics it was exposed to on multiple occasions, which repeats the claim that the overuse of antibiotics causes bacterial resistance. In the end, our hypothesis was correct.
Which ultimately comes to the conclusion that the use of antibiotics should be avoided unless completely necessary. Overuse of antibiotics can cause bacteria and other microbes to become resistant, which can render the antibiotics useless. Unique and unheard of antibiotics should be developed and tested due to the fact that their bacteria are evolving rapidly.
Bacteria plays a big role in everyone's life. They provide many beneficial uses in humans and in nature, but also can be very harmful. Bacteria adapts and changes to be more resistant to antibiotics, making antibiotics less effective to maintain the health of the human population.
Effective antibiotics are slowly becoming scarce and are more important now than they have ever been. If antibiotic use is not controlled, which means cutting down their overuse and misuse, and even limiting their number of antibiotics we feed animals, bacteria cause disease, infection, and illness could once again be a very serious threat to the human health.
Thanks for watching. Any questions?